Good morning, everyone. I'm Yuri and we're gonna write some code today. Let me know if everything is all right, video, audio, and let's get started. Also, Christos Voskres, to whom it may concern. Happy Easter. Happy Orthodox Easter. Christos Voskres. The video should be all right, but I'm still waiting for your information, for your feedback. And good morning, everyone. Also, where you from? At least the guys who could write something in the chat. Yay! Hey everyone. Because it's kind of a holiday today in my country, I wanted to make a bit of a short stream, but still let's have some fun. Hey to the France. Good morning, everyone. Hello. Alrighty. Morning, everyone. Nice to see you all. Okay, so today I'm gonna be recreating the GIF by one of the amazing guys. Morning from Kiev. We have a clean air finally. Almost clean air. So I'm really a fan of Étienne Jacob GIFs, and sometimes I got inspired by some of them, and this is, I think, one of the famous GIFs originally done by him. I'm not sure, but I think it's by him, his style. And I wanted to show you how easy it is to create, and I hope it will inspire you, and I hope that Étienne Jacob would wish the same, to inspire people and to recreate those GIFs, because he shares the code. And this one, I don't think he shared the code, but I just like to create something. When I see something visual, I like to create it myself. Hey, from Dubai. Oh, we have some geography today. Not many people, but all around the world. All right. I'm glad you're here. Let's go. So we're going to be creating this. I'll start with a simple Three.js template. I could also start with a canvas sketch. Last time I started with canvas sketch. It doesn't really matter where you start. It's nothing special about this template. But this time I'm going to be using the template. Maybe later on we could switch to the canvas sketch and do something else. So in this template I have a basic JavaScript file to set up a Three.js scene, and I'll make it bigger. That's not this. Yeah, it is. It's also kind of an art when you make something infinite. Not a finite GIF, but an infinite GIF. Oh yeah, I got some shit in my JavaScript. It's quite handy to have those shortcuts. I mean, at least for me. I also have the V shortcut, but I happen to like Sublime a bit more than the Visual Studio Code. Yep. So yeah, I have this broken module here. Just remove it and it should be good. It's not yet, because maybe. Yeah, so now we have just a simple plane. We are seeing UVs and we have the vertex and the fragment shader all in place. That's where we start. So yeah, again, it's nothing. Even though I have some code here, it's just like the basic minimum code that you need to set up. Well, I have this some other shit which is not usually working properly, but just gonna remove it. Okay, so obviously to make something like this, we need some particles, and we need some instances, some kind of objects. So let's start with the particles. It's not like we're going anywhere after the particles, but let's start with them. Okay, so when you want to make particles and when you want to make them custom with a custom positioning, and when you want them to be animated later on, not on the CPU, it's good to have a shader material for them. And when you have a shader material and when you want to set up a position for each of the particles, I think the easiest way is to use the buffer geometry. Instead of using the plane geometry, by the way, I think I can just do this. Even though I'm using just the plane geometry, I can set up particles like that, probably. Let's try it. I haven't tried it, but it should be working like that. So yeah, the second thought, I have two kind of shaders in my template, and the only difference between them is, okay, besides some code that I need to delete years ago, I need to delete it. Besides that, I only have those two lines which set up the size of the particles, depending on the, how far are they, and etc, etc. So I will change my vertex shader from this kind of basic shader to super duper particles shader. To do that, I'm gonna just change the dependency here, vertex particles. And this is also the other good thing about the parcel, that you can just include shaders, and well, you can just include anything. Other files would just got included at the URLs, but GLSL, it just installs GLSLify or something like that, which bundles it as a string, so we can use it as a shader material parameter. Alrighty. Yep. What's next? So now we have the plane geometry. I should probably see something right now. Yeah, I'm seeing, but the particles are too damn huge. I need to make them small. I have this coefficient here, so maybe, yeah. So yeah, you can actually create the particles from the basic geometries in a 3GS. So I can even do something like this sphere. This is the easiest way to do this, I think. And I'll just get a sphere, the particles. All right, but I don't need all of that. I just need the buffer geometry, an empty one, because I want some custom kind of, maybe I don't even need the custom, but yeah, let's stick with the custom. To do the custom, I will need to set the position attribute. So first I'm gonna introduce this variable, and it's gonna be, and I obviously need to have some kind of count of how many particles I will have, and I want a lot. Let's say 500, but I'll have them, not the count, I'll have the count squared and then multiplied by 3, because each of the particles should have three values for the 3D coordinate, right? Yeah, then I'll have the loop called punt. Okay. Happy Easter, Eddie. And I'll have another loop for the same. And well, then I just need to set some kind of position on my screen. And after that, I will need to do this. I will need to do this geometry set attribute. I'll need to call it the default name. And then u3 buffer. I think I'm starting to remember all the 3JS names and APIs. Kind of bothers me. And yeah, it's gotta be just position and then 3, because we have 3 values for each of the particles. Okay. There we go. Now we need to set. To set, we could use set method of the float array, and it's gonna be like this. But we have 2 loops, so that means that we need to do this position set, and then we need to set the position where we set the position, right? And this is gonna be count multiplied by I plus j. Yeah, because or we could have another index which is gonna be thrown inside a loop. But yeah, maybe it's better to have it this way. Then I can just set the random values for now. Yes, I think we have the random values. It's not looking quite good, and I think I know what bothers me, because when you try to look from a different angle on this particle cloud, sometimes some particles disappear, and this is a behavior that I don't like, and I need to remove it. I think I also need them transparent. Yeah, I think it's a bit better. They're still all black, and I still have everything white. I'll change that now. I'll make my canvas black. Yeah, now we have the black particles on the black background. This is the perfect setup for any kind of animation. And I'm gonna spoil it by changing the color of the particles, because I can set the color of the particles right here. How about red particles? Oh, it's actually yellow, yeah, because I said yeah. Yeah, now I have red particles, which I also don't like, because I think I need them to be what color? White, obviously. Let's make them white. Now I think I need to make them circles. To make them circles, I could use an image, but I could also use a simple math inside my particle shader. I think we have this built-in in here. Yeah, and we have kind of UVs inside. Now I could do the I could calculate the length of the vector, and the vector is going to be this minus the center of the particle. So now this should be showing me the distance from the center of the particle. Does it? Yeah, it kind of does. So now I have to take the smooth tab, so I can do the float alpha equals smooth step. And well, this changes from the 0 to what? To 0.5 on this edge of each particle, because this is the distance from the center and the particle size is 1, so this is 0.5, and so I need to step on a 0.5 range somewhere. So I can do this on this dist. Now I want to see this alpha. What? I think I messed up. Yeah. So now we're almost there. Kind of wanted to remove this. So now it's going to be the red where the alpha is 1, which is not what I want. I want it the other way. And now I can set the yeah, it's still showing me. Set the alpha here, set it's particle white. What? Yeah, 2 dots. Yeah, so now we have the perfect circle particles. So good. They're perfectly, they're smooth. All right. Now I want them to be in space. And for them to be in space, I kind of want it. Actually, I'm gonna kind of replicate the thing that I just did with the 3GS geometry, and I'm gonna spare them in the space. Scatter them in the space, right? Oh. All right. For that, I will just use this count and the ij things. I think I'll set one of the coordinates to 0, probably z, because it's always about z. Z is always 0. I wonder if Z gets set sometimes, because in most of the WebGL animations, Z is just 0. And all the fun goes to the X and Y coordinate. Right, enough of the sadness for the Z coordinate. Let's continue. So I'm gonna get something from 0 to 1 range. I'm gonna subtract 0.5, so now it's minus 0.5 to 0.5. I'll have to multiply it by something big, I don't know, like 50. Then I'll do the same with the J count, and then 0. Yes, okay. Let's see what we get. So we're kind of getting something which is not right. Because why? Why is everything like this? Morning guys, we already have some errors here coming. So this is 0.5 range and this is 0.5 range, and why the hell is it not working for me? Now it's real set. Well, let's make it smaller for now so I can see more of the particles at the same time. This is like some common mistake which I just can't see right now on my screen. Could you see the mistake? Oh, I think I know it's a mistake. For God's sake. Because I have the 3 values for each of the particle. So I need to step with a 3 count, because otherwise I was setting at the same spot, and I don't know, it just doesn't make any sense. Well, now it doesn't make any sense either, but yeah. So there we go. Now we have it. So now we have the perfect plane. We could actually, that's what I was telling you, that we could have actually created this one with the plane geometry. I think we would have a bit less of the control over the positions of the particles, but yeah. Also, because it's Easter, I could show you how you could create an egg with those particles. So this is the math to create the plane. Well, not really hard of a math, but then let's just create something called U, which is going to be the math random, which I'm going to multiply by, guess what, 2, and you can see where I'm going now. Now I have the V coordinate, which is running the same range, and then let's calculate the X. X is going to be, if I believe, it should be something like in a 1 range, but not quite 1 range, and multiplied by sine cosine. Okay, this is going to be 2 sine UVs. Like you can actually see how I stored all these formulas in my brain. It's like sometimes I remember the end of the formula and then the start of the formula and then again the end of the formula. So this should be the cosine of the what? I think it doesn't even matter. I think it should be cosine of the V, and if it's cosine of the V, that means V. So here I need to change the cosine of the U. Yeah, I believe this is right. So that means that maybe it will help you in your life. How I remember this formula without this part, like without this, like this, without this part. This is just the sphere geometry formula. And I remember the sphere geometry because I know that all those 3 values squared should add up to 1. And because the sine squared plus cosine squared is always 1, I know that if I add up those 3 values, I would end up with just 1. yeah, I think I shouldn't do here just something like 0.5 something, so it should be long. Yeah, and it should be y, and let's see what's that. Duplicate it, so it's gonna be x, y. Not sad anymore, you know. Yeah, I wanted something small here. Okay, something is not wrong. Cosine. Okay, yeah, obviously. We need to use math. Well, now we have an egg, but I think we have like we have a double egg, so maybe the ranges are wrong. Let's see. Maybe 0.1 should be enough. No, we're getting like it's also quite an interesting thing to try yourself. Like if we get the 0, 1 range, we just get something like a part of the shell of an egg. So maybe one of them should be running like this. I wonder what's that inside shape happening here. Why is it even there? Well, that's an egg, right? You never know what's inside an egg. No, I'm still bothered, but like, why? Why do I have the inside part? Maybe just one of them should be running to P range. Yeah, that was that. So I think just V should be running to the 0 to math P, and then the other one to the whole range. And now we have it, yeah. We could also multiply this by something big. And now we have a huge egg with 250,000 particles, right? This actually looks like a real egg, right? With such a simple formula. Just go ahead and use it for your Easter animation if you are an Orthodox, of course. Because otherwise you are a bit late and you have to wait 51 weeks. Okay, yeah, this was an egg. We are done with the next. Let's get with the animation. So now we have this plane. I think I want to move camera to be like more something, I don't know, 0.5, 0. So now we are exactly on the plane. Now kind of moving to be maybe like this. Yeah. Shouldn't actually change even this one. Oh no, I should just get out because it's a Z coordinate, the Z one, which we need in camera because it wouldn't work. Okay, so now we have the particles, have them spaced on the whole screen. I think also they're kind of big to me, look big to me, but I think that it's gonna change in a minute. Okay, so let's try to animate this. First of all, I'm gonna include the noise because obviously when you look at the starting animation, it has some waves that look kind of natural, and I need some noise function, which is easy to find. I think I will need it 4-dimensional this time. I like 4 dimensions because it just has another dimension which you can hide in, maybe, I don't know, which you can use for your which you can use for something. Where is the 4-dimensional noise? Yeah, it's, I think it was somewhere in the start. Classic Berlin noise, 3-dimensional. Yeah, there we go. This is a 4-dimensional. Even though it's called 3D noise, but it's actually 4-dimensional noise. All right, so now we have this, not even using all of these things. I don't even need them. So I'll just copy paste the noise function. And this is, well, the easiest way now to do something is that I can just do what? So I can set the new bus, not let, not float, it's like 3, which is equal to position, and then new bus, which coordinate we're going to change. New pos z plus equals, because it's still 0, we're going to just set it as well, equals this noise function, noise, it's noise, c noise it's called. And then it needs the 4-dimensional vector, so we're going to do this, and then the last one is going to be time, because I have time here, right? Yeah, I have the unit for time, and I'm setting it here in my request animation frame loop. So we should have something, but we don't, because I'm not using this new pos variable I just introduced, because I'm still using the default position. I'm gonna separate it. Yeah, so now we have this wonderful kind of animation which you can try yourself. I'll make it a bit slower. That's not the place to make it slower. Yeah, so now it's kind of a cool generic starting vertex animation, but it's not what we wanted, right? So if you look closer here, you can see that the what's that? I don't know. The terrain, it goes kind of to the sky. You know what also goes to the sky? Well, except, okay, I have too many jokes in my mind right now, except some obvious things. Some other math things go to the sky, like x squared, x in cube goes also to the sky, like so much fast. And I think this thing kind of reminds me what I see here, like this slope I have in front of me. And let's try to do that, right? So instead of using noise here, I'm gonna just use the Z, and I'm gonna add something here. But what I'm gonna add? So I have the X and Y coordinate, and let's try to add, and my camera is somewhere in the 0 range. So I'm gonna add the new pos Y, new pos Y squared. Let's try to make it square. Now let's see what's gonna happen. Yes, now we have this kind of slope. It's not what I wanted, but we can make it cube. I think it will go to the sky then. No, we can just multiply it by something negative then. So now we have this kind of thing, but I also don't quite like it because I'm not in control. Well, if I go far from it, you can see that this is the exact function that you see here. And this is what I like, because this is the simple, like one of the simplest math functions that you could get, and you can already get some kind of nice visual effect with that. So I don't want this slope happen so close to my camera. I want it to be a bit further ahead, and I also want my particles to move. So first of all, let's try to move them. So new pos, I hate when that happens. So new pos Y, I'm gonna be adding something, and it's gonna be time multiplied by something, right? Maybe just time. Yes, now we have the particles running from me, and then eventually they run away. But we could do something like this, and it's gonna be infinite, not finite anymore. I'm trying to practice those English words. So it's going to be an infinite animation now. It's kind of fast, so let's make it a bit slower. Yeah, and also want it the other way. Now I could get back with my slope. No, this is not the slope. Now we have this. This is actually already amazing in itself. I like it. What I don't like about this is that the particles go down right before the camera. So I want them to kind of go straight at the camera. And for this, I will use the smooth step function. That I'll use something called progress, probably, and it's going to be a smooth step. And I'm going to smooth step the y coordinate, because y coordinate is kind of a z coordinate for me right now. It's how far the particles are from me. So I'm going to be using the new pos y, and I need two numbers here. So the first one should be something behind the camera, and I think it's going to be like the -1. And the other one should be something in front of me, which is going to be 4. Now let's try to visualize this. So I'm going to multiply this whole slope thing with the progress. Yeah, and I can see that the slope goes further now. So I can move this. Okay, let's try to see it on my screen. So this is simple calculation. I can move it like real far ahead, and we can have all kinds of slope you could get with this. And we're still having the same kind of function, new pos cube, and then yeah, multiplied by progress. Well, I think the 5 or something like that is enough. I also think that the particles should be smaller and a bit more dense. And to make them more dense, to make them smaller, first I will need to change the vertex shader. I'll do something like this here, so that twice smaller. I think I also need to add the blending part. So it doesn't change much right now, but it's going to change the way the particle look when there are going to be lots of them, and then when they will intersect each other. Okay, the next thing. Now I need some noise. I need some noise. I haven't used it, but I actually need it. So first of all, I'm going to change the, so we have the y coordinate like this, we have the z coordinate to the top, and we have the x coordinate like the horizontal from left to right. So now I need to change the x coordinate, because the particles should move sideways. And let's try that. I will just do this. And because this C noise, it actually returns me not the 0-1 range, it's -1 to 1 range, I can just add it and it will move the particles both ways, to the left and to the right too. Yeah, here I'm gonna multiply it by also progress, because I don't want noise to happen. Okay, let's first see how the noise looks like, and then get on that. So I'm gonna use this same thing for now. And position time. Yeah, let's see. Yeah, so it's kind of the noise range are too huge, and you see it doesn't look good when it happens close to the camera. So I kind of need to separate it. Now it happens much better. I think I will need to use some other progress, which is going to be running from a bit further. The noise should start a bit further, like 8. Yeah, so now the noise starts a bit further. and I'll change the slope to go a bit closer. Yeah, I think it looks a bit better. Okay, next, still not quite good. I think it's the change that we're getting here is it's too big. Let's say 0.4. Yeah, it's kind of good. Not quite. Let's see the video. We have too many particles here, much more than I have right now. And this means that I think I should move the should I move the camera closer? Okay, let's first do the noise part. Also, I kind of want to move particles like to the top, because you can see on the video that we have those waves that are pointing to you, and you can see that those waves sometimes are getting like brighter when they intersect each other, and that's where we need the additive blending part. I think I also need to change the YZ coordinates and also do this. Let's see. Yes, now we have it much better. But what I want to do here, to change the shape of those waves and all the parts, I need to recalculate this position. So maybe I should multiply it by 3, for example, and you'll see how it will all change. Yeah, we have much more ways here. So you can already see we're getting kind of close to the original animation. Whoa, we have some math in the chat. Well, it makes it, oh, you can, okay, you've been answering the question. All right, yeah. So I hope it makes it clear, because it means that this whole number is just transferred from the 0 to 3. So we're actually just moving those particles 3 units, and then again 3 units, 0 to 3, 0 to 3, 0 to 3 the whole time. And this makes it infinite. It's the same as in JavaScript. You would make it like time 0.1, not the 0.1. So this will always be between 0 and 1. It's the same. Okay. Now, well, the rest is mostly about figuring the correct numbers, because I have them somewhere in my cheat sheet. I'll just try to replicate the correct numbering, and I'll explain you how I came with the, like, how you would, how you would think to get the correct numbers here. Okay, so first of all, you can see the waves here, and I kind of want to make particles less bright when they go further from the screen. Right? So I'll make the variant called it's gonna be float v progress. I'm gonna set the v progress here. To one of the progresses I have here. I also go to the fragment shader. I have the variant here called v progress. And I think I would do something like plus progress. So it goes something like this, maybe. And it doesn't work because it's not it's just a float. Yeah, now you can see that they're getting white when they intersect each other. Doesn't happen much yet, but we're getting there. I think I will need to move camera a bit, maybe with -1. Yeah, it will get this kind of look to me. And then the next part. Okay. Now I need to calculate noise. Okay, I will do something like this. I will make set noise 1 equals position, and then noise 2 equals position, and then noise 1, noise 2. So this YZ it actually relates to those waves that I have here. So I can set this YZ to something bigger, probably like 0, 1.5. Now we have bigger waves here, and I'll use this progress 1 to make them a bit further from the viewer. Yeah, so the waves stick to the mostly to the wall. Yeah. I think I kind of want to make those waves also the minimum size. So this runs from -1 to 1, but I want them to make it bigger. So like adding something will make the waves bigger. Yeah, it actually makes the waves bigger. Now we have to figure out the numbers. Okay. So if I multiply this, let's start with the noise 2 by something like this. Yeah. Like 1, 5, 1. So it kind of scales position in just one of the axes. And you'll get those kind of waves, which is not what I want really, because I want to scale the other coordinate. I think it's going to be this one. Now you could get the other kind of waves. I think it's too big here. Okay. So the next thing I would like to do is to actually make those waves. Well, somehow the waves are too big or what? I don't know. Maybe I should multiply this by 2. Okay. Now I have to guess the correct numbers here. Somehow maybe I changed the coordinate system or something, and I spoiled the numbers that I should have got by this time. So let me think a bit. Let's try to experiment with numbers and see where we get this. Okay, I think I'll just do some experimenting here. Plus time. Multiplied by something. So I have the position, and I want the position to move also, because those waves, they're kind of static now, and that means that like the particles are just going through some static waves, and you don't see the waves coming down. And to make them coming down, I'll do something like this. I'll multiply this time by what? By some three-dimensional vector, which is going to be like I'm moving. And I'm going to be moving only on y coordinate. So it's going to be 0, 0 0.5, 0, not 0 0.5, it'll be just 1. So I'm moving the position when the time goes down. And that means that the waves should go down too. Yeah, it starts to look, I think something is wrong with the shape of the waves. I'm going to remove this noise first. And the time goes too damn fast again. I think I can just make it less here. Well, just the shape of the waves is not right. Because why? Maybe I should multiply position here. Something big. This is too much. Or is this the wrong noise function that I'm using? So this is what we have now. The particles are coming down, but the waves are not that beautiful. And why is that? Yuri, could you tell us, please? Do you have any idea? Multiplying static, well, I'm already multiplying it by some, I'm even adding something here. I'm just wondering why this shape doesn't look like I intended it to look. Okay, so I need this noise. Something is wrong. Hello, Finland. Hyvä huomio, right? Something is wrong, and nobody knows what. Something is wrong with the like coordinate system kind of thing. So I almost have those waves, but I got some mistake. Sorry about that, guys. That happens. I actually spent like 1 or 2 hours fiddling with those numbers to get them right. Until finally I got them right. Oh, Manta. Boom, 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 boom. How have you been doing, guys? Just tell me something good while I'm stuck on this. I just need a minute. One, two, rubber duck it out. Yeah, we're almost there. And this is the worst part, that you're almost there and just make some mistake somewhere. And I wanted so badly to explain you how easy it is. It's not easy. Not easy. Sometimes. Okay, I'll give it like I give it 2 minutes. If I fix it, I fix it. If not, I'll just show you the right code. So I'm gonna try to debug it now. I think I should have way more particles they are behind. Maybe I should make even more particles. I should make them less separated. I could get this wonderful look. I think it's about the number of particles. I didn't have them enough there. And well, could also move the camera a bit closer to the bottom line. think I did everything right. It's just about the camera and the number of the particles, because if you don't have enough particles, you probably just don't see the noise function there. Yeah, so the camera might pick out the camera also. Yeah, I think we're getting somewhere. Yeah, shaders sometimes are a headache. I think I will return the X change as well. I'll make them the same for now. Yeah, now we're getting all those, like the curtain look. We just need to make them a bit different, maybe. So I need those waves, I need them to be maybe like this. Yeah, it's kind of getting there. I think this noise should go down faster. So this is the YZ coordinate, and this is X is just sideways. I'm not that interested in the side. Maybe I'm interested actually in the sideways. Maybe the sideways is the one that is wrong now. Shouldn't be changing it a lot. We kind of got the amazing animation. I just need to set up the noise now because we have two long waves. And you know what? I know the reason for that. Oh, I know the reason. This is because I'm calculating the noise. Well, it's just so relieving to finding out the solution finally to a headache. This is all like the waves are almost the same because I'm calculating the waves based on the coordinate system, and the coordinates are quite the same on like the slope goes so fast to the top that the coordinates are almost the same. So let's just not use the... Yeah, it's starting to look much better. I also want those waves to move to the bottom somehow, and for this we'll need to do much faster job here. So the waves, like, let's first see which ones are incorrect. Yeah, it's these ones. So these ones I think look kind of... Yeah, I need them more. I need more of those waves. So this function I need more. So I need to multiply this by something. Let's just try to come up with the numbers. Yeah, this is the one. Yeah, this whole time I just needed to multiply it by something. Yes, now we're getting there, and to make those waves move faster to the bottom, I'll just maybe make these things faster. Yeah, now we're getting the look that I was intending to. Now the waves, now you know what I actually did here. If I multiply this by 0, let's see what's gonna happen. They're just kind of moving slowly, and only because I have this time moving. If I multiply this time by 0, it's gonna be just static. But I kind of wanted to, well, let's leave it static, but then this time, now they're moving faster than the particles are moving, because I'm adding something to position and then calculating the noise, and that means the noise travels faster through the particles than the particle travel itself, right? And then we add something that changes the noise, and now we get this look like the waves are coming down. Yeah, here we go. I also think that the particles should be again a bit smaller. The vertex somewhere here. yeah, I can experiment with that. Just a bit smaller, then you get this look. Ooh, it was hard. Actually, you know what's wrong? I did everything right. This is what's wrong. And I started to doubt myself because I did everything right, and I just messed up some, coefficients. I just needed to continue that. Yeah, that's it. Okay, so I will enable the adding noise now. And now we get this look. Well, again, of course, you can play with it a bit more and get the other look. So let's try to experiment with a bit. So instead of adding something, I could just subtract something, and then you get the other animation. Something like this, even like this. It's all in itself looks like an art to this. You can also multiply this, or maybe add to this the other parameter squared, like the x. The x goes from left to right. So let's add the x squared. You can think for 2 seconds what's going to happen. You can try to guess. The x is 0 in the center of the screen and then grows to the left and to the right. And that's what you get. So if I just subtract it, I'm gonna get this kind of curve, which is also kind of cool. You would need to play with the noise position, of course. Make this plus, then you'll get this kind of the waterfall, I don't know, this kind of thing. And this is all just math, so this is just 2 parabolas combined in a 3D space, and just some noise function which sets the noise not everywhere but on a part of the screen. And you can actually play with it a lot. To make this loop, I wouldn't be making it right now, but to make this loop, you have this kind of progress here, u plus y. This is actually the progress of our animation. It goes from 0 to 3. You would need to make all those parts as sine or cosine functions, so they are periodic, which are dependent from this y coordinate, and that will make the whole animation infinite, not finite. So yeah, this is it. No triangles today, just this infinite GIF animation. Hope you liked that one. And go subscribe to the Étienne, who's also known as Necessary Disorder. Étienne Jacob. Yeah, go subscribe him. Eugene actually might be right. It's just that with a different approach, you would get the different set of animation. Maybe specifically for this one, it could be easier to create a sphere or maybe a torus, and then just rotate it, and then you'll get the loop by default because you would rotate it the whole way around. So it might be easier. But with this one, you could get like all those different kind of shapes, like where you could distort this terrain with the math functions and then do it. And also like looping it with the, well, sometimes you just can't get around with a sphere or something rotated, and you just need to have the noise with a loop. And to make the noise with a loop, you would need those sine and cosine functions. So it's really an easy one. I spent some time explaining it. Like we spent some time, I had some mistakes. I hope you understood how I fixed them, because it's just about the correct numbers and playing with the numbers. And usually all this GIF art is about playing with numbers. Sometimes you get something ugly, then you just change the numbers and it's all beautiful. And sometimes you occasionally get something beautiful, and like if you put any other number, it's just ugly. So yeah, hope you liked that one. Hope it could inspire you to create some of the GIF yourself, because it's not really hard except when you make mistakes. And I hope you like this explanation. Not much of a code again. I'm showing the whole code right now, and well, yeah, a little bit of the code here, and also yeah, just some basic code we set in the particles here, in the position of the particles. I wonder what happened if I just change everything to the egg again. It should be something real broken. It's actually kind of beautiful, right? In itself. Maybe I will experiment with it a bit and come up with something. This is just an egg geometry with the same animation I just used for the... This is actually kind of pleasing kind of shape that I get when I distort the egg shape with the parabolas. Yeah, okay. So yeah, now you see you could experiment a lot. Thanks everyone for being part of my morning today. I kind of want it to be simple. Next time it's going to be something a bit more special. And yeah, thank you. I hope your day will be good. You might celebrate, call your closest ones, take care, stay safe. I love you all. Write me in the Twitter if you have some feedback or something. Have a nice day.